In this video, we'll find out what a voltage follower is and see why it's a particularly useful configuration. Suppose, in our non-inverting amplifier, instead of a resistor divider circuit, we establish negative feedback by directly connecting the output and the inverting terminal. We get a circuit which looks like this. This is equivalent to a non-inverting amplifier with R1 infinity and R2 equal to 0. Essentially, we're shorting the output with the inverting input. So the voltage Vx will be equal to Vout. As the op-amp is in negative feedback, the two inputs are virtually shorted and are at the same value. So, Vin is equal to Vx, which is equal to Vout. As Vin is equal to Vout, we call this configuration the voltage follower. The gain of this circuit, Vout by Vin, is just 1, as you can see. You might wonder, if there is no amplification of the signal, why should we be using such a circuit? For that, you need to keep in mind that an amplifier, or rather any integrated circuit, does not consist of just one op-amp, rather it is built by cascading several stages of amplifiers in different configurations, each with its own merit and purpose. Consider two stages of a circuit where the output of the first stage is given as input to the second stage. If the second stage has a low input impedance, it draws a current from the first stage, and there will be significant attenuation of the signal. Now, let us add a voltage follower in between. The beauty of the voltage follower is that the input impedance is infinite, and the output impedance is 0. Hence, this circuit behaves like an intermediary, and isolates two different stages of an amplifier. The voltage follower does not draw any current from the first stage, and transfers the output of the first stage to the input of the second stage without any attenuation. That's why even though we don't essentially have any amplification here, it's still one of the most useful op-amp configurations. Due to this isolating action, a voltage follower is also called a buffer. We can also represent a buffer simply by a triangle with one input and one output. In this way, we often have to incorporate several buffers in between various stages of integrated circuits, as shown. By adding these buffers, we achieve isolation between stages. That's all for the voltage follower configuration. If you have any doubts, feel free to ask in the comments section. Don't forget to like, share and subscribe.